Hello all and welcome to this series of videos where we look at matrices. This is going to be a pretty basic look at them where we look at what is a matrix, we'll look at addition and subtraction of matrices, scalar multiplication, matrix multiplication or also called vector multiplication, and then we'll also look very briefly at the identity matrix and finding the inverse of a matrix because that's what we need to be able to do division. But let's get straight into it. So a matrix, as can be seen here on the right hand side, you can think of that as a table. It's a table that stores values, and whenever you're dealing with any sort of computer like say a matrix, like Excel or any software that's dealing with tables, essentially in the back end is what it's running is some form of matrix to store all those values. They're really, really important. I can't stress this enough. It's in the back end of it, any software, it's generally a matrix that's doing calculations. Matrix used in game design when you do what's called vector space and you translate, say the game world is built in a digitally 3D world, but that needs to get translated into a 2D image on your screen while they use matrices to do what's called vector space calculations. Is one example. They come up in both further and methods, so it doesn't matter which pathway you're going for Year 12, this is some critical skills. Right, the questions are all the questions from the worksheet, and then at the end of each section we'll tell you which worksheets to do. Right, so let's get going. So a matrix, like I said, stores data. We have rows and columns, so we'll start with rows. This is row 1 here. We have row 2 there and row 3, etc. And then going down in the columns, these columns, they are, in this case, it's test scores, so test 1, test 2, test 3, test 4. And that's all data represented. Just think of it sort of like an Excel table. For matrices, we name them using a capital letter. So unlike all the sort of general variables that we're doing, which would be lowercase x, a, b, h, k, we're going to use capital letters. So x, a, and b are the very common ones that are used. So that's what we will be using, matrices for capital letters. In this case, this one is called A. We can see it's got 3 rows and it's got 4 columns. So columns are vertical. As we can see, they run down vertical, but we count them going across. That's it's a bit like longitude and latitude, as the lines go one way, but they're measuring something going the other. And rows are horizontal, and we describe the size. And when we talk about a matrix, when we talk about the size, we actually call it order. And we state the row, how many rows there are, and then how many columns they are. So you could think of it as it says here, like when you're entering a theatre, you have to count how far down you're going, which is what row, how many rows there are, and then you go across to your seat, so that's going across to the column. The other way I think of it when counting an order is I just think about sort of a drop and then slide across. Is we drop first, or we go down the aisle, and then we go across to our seat. So a drop and then a slide. And if we count those, then we have the order. So in this case, like I said, we go down 3 rows and we go across 4 columns. So this is considered to be an order of 3 by 4. So that's the size of the matrix. Now, not only do we use this system of talking what row and then what column are in for the size, but also we can reference individual elements. Okay, an individual entry is called an element of the matrix. We can reference individual ones. So in this case, we've got A13. That means I drop down to the first row, and then I'm going to go across 3 columns. Means I'm going to have 73. So it's the third test score of student 1, because I went down to student 1 and then across to test 3. If I had A32, that rule, this is, yes, we go down to student 3 and then we're going to go across 2. So as it says here, that is the second test score of student 3. Or I've gone down to student 3 and then across 2. So that's how we talk about individual elements and also the size of a matrix. Right, so quick work examples. Matrix B is shown, represents the different class sizes for 11 VCE Maths in 2020. Now this was at my old school, but it was Real Data. We were a much larger school, so there was 4 methods classes. We had a specialist, and there was 5 general maths classes. So state the order of the matrix and interpret what the rows and columns represent. So very first, we're going to drop, so we've got a 3, and then how far we're going to slide across, we've got 5 data sets. So the order is equal to 3 by 5. Now, what do the rows represent and what do the columns represent? Columns, it would help if I spelt. Okay, so the rows are the subjects, so subject types, we should say. And then the columns are the class numbers. And then the individual number and size of the number of students. So write down the information that is given by B35, and that's the one thing I forgot to say. When we refer to an individual element, a single bit inside, we use the same letter as the name but in lowercase. So in this case, this matrix was called A, capital A, and then individual elements inside it are lowercase. So write down the information given by B35. You can also get in the habit of putting a comma in between there, because when you get into a real world situation where matrices could have hundreds of rows and hundreds of columns, is this B35 down 0? What is this? Is it 35 0 or is it 350? So don't be afraid to put commas in there, but 35, so we go down to 3, across to 5 is 23. And that tells us the number of students in general class number 5. How many students are doing methods? Well, we want methods here, and we need to sum up all of those. So 20 plus 22 plus 18, that is 60 plus 19, so we have 79 students. And then it asks us, finally, what element gives us the number of students in class 2 doing general maths? So we want class 2 doing general, so we can see that as 25. So we might say B32 is equal to 25. Or we could say 25 students in class 2 are doing general. Rightio, a little bit of practice. Identifying orders. So what's the order of this first matrix? Well, think of that drop, then slide across. So we drop down. There are 5 rows, and then we can go across 2 columns. This matrix here, we can go down 3 and then across 3, so it's 3 by 3. And any time where the rows equal columns, that is called a square matrix. It's quite handy to know. This one here, we can go down 5, but we can only go across 1, so this is a single column, and that's called a column matrix. And then we can also have this 1 by 3 matrix, which is a row matrix because it's just a single row. We only can go down 1 row and we can go across 3 columns, so it's called a row matrix. Lastly, you can enter these all on your CAS. There is instructions here. I might just bring up ClassPad software. Hopefully it loads quickly. You can enter them either directly as a... Let's clear all of this. Okay. And then we go into our main keyboard. It is in, I believe it's in Math 2. Right in the middle of Math 2, there is the matrix enter, and that gives you automatically a 2 by 2. Now, if you want a bigger matrix, you can press it again, and that just keeps expanding the size in terms of the square matrix. But what if you wanted a 3 by 4? Well, go up to 4 by 4, highlight all of those, and then hit clear, and that'll delete a row. So that's how you can adjust it as need be. I believe you can also put in, under action matrix create. No, that's going to be an action. That's going to change a matrix. No. We'll just leave it with pressing that button and then deleting out any rows or columns that you don't need. Well, that's how you can get a matrix. You can enter any of the numbers in it, and then you can also store them. So where is it here? Using the store button. It's in Math 1. So we might want to store this matrix that has 1, 4, 3, 2, 3, and Math 1. We want to. We need to click outside of the matrix. We want to store it, and we want to store it as A. Done. And then if we need to do that, use it later, and we could do some matrix calculations in your CAS as well. So that's really handy to store it. Yeah, that's how you can put it in. Rightio, that's first video done. Nice and straightforward. Oh, do we have any practice questions? Not yet. But yeah, that's first video done, so there's no questions to actually do from the worksheets just yet, but a quick introduction. Make sure you have your head wrapped around the notation about individual elements, because that'll be really important when we start talking about addition, subtraction, and especially multiplication of matrices later on. That's it. Have a good day.